Hi everyone, so today we're going to learn how to use R to conduct a t-test on our data. There are a lot of different kinds of t-tests. They basically test for a statistically significant difference between averages. And I'm just going to go over the two most basic kinds today for the sake of time. So the first thing that we're going to do is we're going to get our data into R with the trusty read.csv file.choose function, which is right here. I'm not going to call it data. I'm going to call it Jimmy. Not up there, not up front. I want to call it Jimmy back here. Jimmy, Jimmy. Just to demonstrate how you can call it anything. So I have some data here, and we're going to load it. We're going to type in Jimmy, and Jimmy means this. So I'm going to analyze the difference between these two variables right here. So there's a lot of ways to do that. Typically what most people would do, regardless of the package they have available to them, is they're going to add the t.test function, which is going to look at the two variables of interest that can be delineated with the function your data name, $, and then variable name. So this is Jimmy, the data, the variables CTA and GTA, and then you add a little $sign in the middle, and that's how you get that. So we're going to run a t-test between CTA and GTA in my data set that I have so gingerly named Jimmy. And we have a Welch Two Sample test. But the weird thing is that a Welch Two Sample test, it's more applicable for unequal sample sizes and unequal variances. In other words, a Welch Two Sample t-test is usable for two different samples as an independent samples t-test. But these two groups are actually the same people. The same people doing the same thing, two different settings. So I'm not going to use an independent samples t. I'm going to use a regular t-test where I'm going to assume that the variance is equal. So there's another code that I think is better than the Welch Two Sample t-test. And we're going to do that. And we're going to observe the differences between the values that it spits out. And we're going to look at a t-test between my data set named Jimmy, and we're going to look at the two variables, but the difference is that the variances are equal. And we're going to have the code variance.equal equals true. And that will give us a regular two sample t-test. And this is, as I said, especially good for tests where you're going to only be looking at one group's data from two different positions. So you want the same population, the same methodology. And that's the most reliable way to do it. So I like this Welch Two Sample t-test because it doesn't assume that it doesn't assume that the two groups are different. It assumes that the groups are the same. So it's it has more fidelity, so to speak. So for the two sample t, we have a t of 2.09, and we have a p-value of 0.04, which is statistically significant. And for the Welch Two Sample, we have really similar values. I mean, off by a very small amount. But if you have a bigger data set than just 21 instances, you're going to find that this stuff really, really matters. So for the Welch Two Sample, we have a t of 2.0967, which is the same as this one down here. We have a degrees of freedom, which is actually off by quite a bit. You see that we have about 4 degrees of freedom different between these two. And the p-value for the top one, for the Welch, 0.04313 versus 0.04239. This is actually more significant than this one. And we're still using a 95% confidence interval, or an alpha of 5, if I remember correctly. So just if you're going to be running a test between two different groups use the Welch Two Sample. If you have questionnaires that you're giving to one group of people about how much they like Pepsi or whatever, versus another group and you ask them how much they like Coke, that would be a good use for the Welch Two Sample. And for a test of the same group doing two different kinds of the research that you're doing. So let's say you have one group filling out a questionnaire in one condition, let's say like before they go to bed. And then you have the same group doing a questionnaire when they wake up. The same group, same end, same questionnaire. You want the regular two sample t-test with equal variances assumed. So I hope that clears a lot of stuff up about t-tests and how to do them. As always, the codes are in the description below. And I hope this was helpful. Like and subscribe. Comment with questions or suggestions, and I will answer them with all possible speed. Thank you so much for watching.